All right, this is the honors midterm review. Make sure you have a calculator, your reference table, and a place to do some scratch work if you need to. Okay, so the diagram below represents a portion of a 100 milliliter graduated cylinder. What is the reading of the meniscus? So the meniscus is the curvature, the lowest part of this line here. So there's that. So where is that? So let's take a look at the scale. This is 30 milliliters. This is 40. So 1, 2, 3, 4, a larger line, 6, 7, 8, 9, 40. So each of these lines is worth 1 milliliter. And since we're right at that darker line that's midway, so it's 35. So 35.0. And the reason why it's 35.0 is we are sure of the 30. We're sure of the 31, 2, 3. We're sure of the ones place. But we're not sure about the tenths place. That's where our estimation comes in. So that's why we can only go to the tenths place. All right, number 2. Which set of laboratory equipment would most likely be used with a crucible? So remember, a crucible, I can't draw. It looks like a little acorn with a hat. So crucible, you're going to need to support it with a clay triangle. So not those. So what would be the crucible tongs? It would be choice A. These are test tube tongs. Which Kelvin temperature is equal to 200 degrees Celsius? So don't forget, on reference table T, it provides, and I have my reference table here, you can hear the pages. The formula is whatever Kelvin equals degrees Celsius plus 273. So 200 plus 273 is 473 Kelvin, choice D. A portion of a burette. A burette is kind of like a graduated cylinder, except for it has a valve at the bottom to distribute volume of liquids very accurately, drop-wise or a steady stream. What is the reading in milliliters? So all of these are in milliliters. So let's take a look. So in a burette, 0 is at the top and 50 is at the bottom. So it doesn't matter that it's opposite a grad cylinder. It doesn't matter. So we have 16 here. We have 17 here. So we're sure of the tens, the ones. We're sure of the tenths, because that's what all these lines are. So we'd have to estimate to the hundredths. So 16.1, 2, 3, 4. So 16.4 is that line, but we have to go to 16.40 because we estimate the hundredths place. Okay, so another grad cylinder. So here's 70, here's 80. So this is 71, 2, 3, 4, 5, 6. So we're sure of the tenths. We're sure of the ones, but we're not sure of the tenths. So we cannot go to 2 decimal places. We can only go to 1 decimal place. So let me check again. So 71, 72, 3, 4, 5, 76 is up there. So actually it's not 76. It's not quite 76. It would be 75.7, I guess. It's a little bit more than half. So it cannot be this because that's too many decimal places. It would have to be choice A. Which temperature change indicates an increase in the average kinetic energy of the molecules in a sample? Average kinetic energy is temperature. So which one is an increase of temperature? First things first, we need to convert everything to the same unit. Doesn't matter if everything's Kelvin or everything's Celsius, it just has to be consistent. So I know that if I add 273 to everything Celsius, that's easy. So 15 plus 273 is 288. 288 to 298 is an increase, so that's probably our answer. But you know what? I'm just going to go ahead and check. This is 310 Kelvin going to 273. That's a decrease. 0 degrees Celsius is 273. That's, again, a decrease. And 25 plus 273 is 298. So notice all of those are decreases. It is indeed choice A. Number 7, an aluminum sample has a mass of 80.01 grams and a density of 2.70 grams per centimeter cubed. According to the data, which we don't seem to care what the answer is, what number of sig figs should be in the answer? So again, density is mass over volume. So mass is 80.01 and this is 2.70, which again, we don't need the answer, but notice this is 4 sig figs. This is 3 sig figs. When you divide, your answer should be rounded to the fewest number of total sig figs, which is 3. So that's why it's choice C. Which unit is used to express an amount of thermal energy? So right on the front of the reference table, table D, you look and it says gram measures mass, mole measures amount of a substance, joule measures energy, work, quantity of heat, and a Pascal is pressure. So it has to be joules. So that is table D, reference table. Which quantity of heat is equal to 200 joules? So 1,000 joules is 1 kilojoule. So 200 joules, 20 kilojoules. So let's see, we would multiply by 1,000. 20 times 1,000 is 20,000, so that's not it. 2 times 1,000, oh, that's 2,000. But we want 200. So 0.2 times 1,000, that's our answer, choice C. And then this would be even smaller. So this is conversion factor is important. Kilo is 10 to the third, so that's larger, which has 4 sig figs. Okay, so let's talk about this first number and B. So A and B are numbers less than 1, which means you start at the decimal place and you move from left to right. So I skip that 0 and I count 8 and 6. So that has 2 sig figs. In part B, I start at the decimal place and I'm going to count all 3. In part C, I have a number greater than 1 without a decimal, which means we start where the decimal place would be, which would be here after the 3, and we start moving from right to left. And as soon as we hit something that's not 0, we count it and everything else to the left. And that first digit is 3, so count it all. So that's my answer. This would be 3 sig figs. Expressed to the correct number of sig figs, the sum of 2 masses is 445.2 grams. Which of the 2 masses produce this answer? So when you add or subtract, you're rounding your answer to the fewest number of decimal places. And since this only has 1 decimal place, we need to look for an addition or subtraction that involves something with 1 decimal place. So A doesn't have that, B doesn't have that, C does have that, so that's our answer. Oh, sorry, this was, oops, number 10 is C, not 4. 4 was number of sig figs. So a student collected the data shown below to determine experimentally the density of distilled water. So again, density is on table T, it's mass over volume. Based on it, what is the density? So the grad cylinder and distilled water is 163. So the mass of the empty grad cylinder is 141. So we're going to need to subtract those. And I'm sorry that the type is a little strange. So we're going to fill this in. This is going to be 22 grams. And we know the volume. So 22 grams, and this is our volume. So 22 divided by 25.3 is 0.86956 and blah, blah, blah. So you go with what's closest, which is choice C. Given. What is the product expressed as the correct number of sig figs? So when you multiply or divide, you round your answer to the proper number of sig figs. I'm sorry, the fewest number of sig figs. So this first one has 3, this has 4, so our final answer should have 3 sig figs. My calculator gave me 63.8564. So that means I'm going to count this, this, and this. Does a 5 round that up? Yes. So 63.9, which is choice B. The solid object shown below has a mass of 162.2 grams. What is the density to the proper number of sig figs? So, of course, density is mass over volume, and it says we have a mass of 162.2, but we need the volume. This is a regular solid, so it's going to be 6.0 times 3.0 times 2.0. So 6 times 3 times 2 is 36. And this has 2 sig figs, so does this, so does this. So 36 is our answer, which means when we divide, we should have 2 sig figs. So my calculator gave me 4.50555. And so since we only want 2 sig figs, since that's the fewest number when we divide, we're going to choose choice C for number 14. A student measures the mass and volume of a piece of aluminum. The measurements are 25.6 grams and 9.1 cubic centimeters. The student calculates the density and what is the percent error. Okay, so first we need to get the experimental, which is what the student got. So 25.6 is our mass, 9.1 is our volume. So let's divide those. And we get 2.813, whatever. Excuse me, so we're going to go to 2 sig figs, so that's going to be grams per cubic centimeter. This is our measured value, or our experimental. I'm going to go to reference table S, and on table S, it will give me the actual value of aluminum's density. Aluminum, it says 2.70. So the formula for percent error is on table T. So you subtract those and then divide by the accepted times 100. So 2.8 minus 2.70 is 0.1. So 0.1 over the accepted, which is 2.70. 0.1 over 2.70. And then you have to multiply by 100. So 3.7, blah, blah, blah. So 3.7, it looks like they want us to round up to 4%. Since it didn't ask for sig figs, it just kind of wanted us to do it. Okay, so we have another percent error. A student intended to make a salt solution with a concentration of 10 grams per solute, 10 grams of solute per liter of solution. When it was analyzed, it was found to contain 8.90 grams of solute per liter of solution. What is the percent error in the concentration? So intended to make 10, that means that's our actual. We actually have, oh, sorry, whoops, measured, but the measured is this. So 10 minus 8.9, I suppose I shouldn't have needed to use that. Numerator 1.1, divide it by our 10, which is the actual, times 100. And you get 11%, which is choice C. A 10-gram sample of H2O liquid water at 23 degrees Celsius absorbs 209 joules of heat. What is the final temperature? So this is a formula on table T. It's called Q equals MC delta T, which we're going to have to adjust slightly because delta T is defined as T final minus T initial. So since we're looking for a final temperature, I'm going to substitute in T final minus T initial. So Q is 209, mass is 10.0. The specific heat of water is found on reference table CB, right in the front, 4.18 grams per cubic, 4.18 grams per degrees, joules per gram degree Celsius or Kelvin. Now, T final is what I'm looking for. T initial is 23. All right, hopefully I don't run out of too much room. So this is 10 times 4.18, which is 418, times TF minus 23 equals 209. Divide both sides by 418. I'm going to have to go over here now. So this is 0.5 equals TF minus 23.0, which means add 23 to both sides and you get 23.5. Oh shoot, did I screw up? Is it 0.5? I did something wrong. Hold on. 10 times 4.18 is 41.8, not 418. Oops. So 209 divided by 41.8 is, it is a full 5. This is not 0.5. Sorry, this is 41.8. See, I make mistakes. So 5 equals TF minus 23. Add 3 to both sides. So it is not 23.5. It is 23 plus 5, which is 28. What occurs when a 35-gram aluminum cube at 100 degrees Celsius is placed in 90 grams of water at 25 degrees Celsius in an insulated cup? The important thing to know is heat flows from hot to cold. So who's hotter? The cube, and the water is colder. So heat is transferred from the aluminum to the water. So not those. And what will happen to the temperature of the water? It will increase. Choice B. Which property is a measure of average kinetic energy? Average kinetic energy is temperature. They are synonyms. A sample of helium gas is in a sealed, rigid container. What occurs as the temperature of the sample increases? So, helium gas and the temperature increases. So that's not going to change. That's not going to change. That's not going to change. None of those are changed by increase in temperature, but they're going to knock around a lot more. Which sample has the highest average kinetic energy? We don't really care about any of this. All we care about is who's at the highest temperature, which is choice B. Which temperature is equal to 120 Kelvin? So I need to add 273 to both. So this is 120 Kelvin, so that should be our answer. Just for kicks, I'll do the rest. This is 153 Kelvin. This is 566 Kelvin. And this last one is 666. So yeah. Which process is exothermic? Exothermic is heat is given off. When you boil water, you need to heat it up on the stove. So you need to take heat in. No. Melting of copper, that's solid to liquid, which means you're taking heat in. No. Condensation of ethanol vapor. So condensation is when a gas becomes a liquid. When you exhale on a cold window, you see your water, the water droplets from your breath. That is getting cooler. So that is our answer. Sublimation is solid straight to a gas. We haven't really talked about that yet. I need to erase. The temperature of a sample of water changes from 10 to 20 degrees Celsius when the sample absorbs 418 joules of heat. What's the mass? So again, this is Q equals MC delta T. I'm going to erase this now. I guess I'll use a different color. So we're looking for the mass. So Q is heat. M, I don't know. Specific heat of water, so that's 4.18 found on the reference table. And T final minus T initial, so that's going to be 10. So 4.18 times 10 is 41.8 times M equals 418. Divide both sides by 41.8. 418 divided by, I should know this, but it's 10. So it's choice B. Okay, which formula represents a mixture? Mixture would have to be aqueous because this is a solid LiCl in H2O, and it becomes a homogeneous mixture or solution. Number 26, bronze contains 90 to 95% copper and 5 to 10% tin. Because these percentages can vary, it is classified as a mixture. Again, this would be called an alloy. Compounds are definite. These are definite, and substances are both compounds and elements, so that's not it. Mixtures, composition can vary. Water is always H2O, but bronze, look at it, you've got different percentages. A mixture of sand and table salt can be separated by filtration because they differ in boiling point, no. Density, no. Freezing point, no. Solubility in water, yes, because who will dissolve in water, sand or table salt? Salt will dissolve. Sand will not, which means when they go through the filter, salt will be in the water transferring through, the sand will be left. Number 28, at room temperature, sand and, okay, here we go, can be separated by filtration because they have different solubilities. When a mixture of water, sand, and salt is filtered, what passes through the filter paper? So what is dissolved in water is the salt. So salt will go through the filter paper with the water, the sand will not. It's a little redundant. Equal amounts of ethanol, alcohol, and water are mixed at room temperature at 101.3 kilopascal. Which process is used to separate the alcohol, ethanol from the mixture? So separation, oh, look at that, from. I think that meant to be from. That is the separation of alcohol and water. That is difference in boiling points, which is called distillation. These are not. Filtration has to do with particle size and our dissolvability or solubility. Which sample of matter can be separated into different substances by physical means? So that has to be a mixture. So the only thing that isn't a pure substance is A. That is an aqueous LiCl, the lithium chloride salt in H2O. 4 statements about the development of the atomic model are shown below. What is the correct historical development? So going from oldest to most recent. So the oldest would have to be hard indivisible spheres. This is Democritus from the ancient Greek days. So it's not those. And then what comes after that? We've got plum pudding. So that is atoms have small negatively charged particles. So that's going to be D to a B. Oh, they both go D to B. So this is J.J. Thomson. The center of an atom is a small dense nucleus. This is Rutherford. That comes next. And wave-like properties. This is Schrodinger. So D to B, C to A. So choice D. Coffee time. Petroleum can be separated by distillation because the elements in petroleum are... Okay, so how do you separate... this is a mixture here. So petroleum is not... Hold on a second. You got to read the whole thing. We separated with different boiling points. So get rid of those. The only way we could separate them is if they had different boiling points. So then we say, all right, hydrocarbons. Now maybe this is confusing because we haven't really talked about this yet. That's something like this. CH4 is a hydrocarbon. So that's a compound. So there's that. If you were to choose B, it's wrong, but it's not that bad. I mean, it's bad, but it's not the worst. Which particle has a mass that is approximately equal to the mass of a proton? So this is on reference table O. It tells us the masses of the subatomics. The mass of a proton is 1 AMU. So that's the upper left corner in the notation. Alpha particle is 4 over 2 HE, which means a mass of 4, which is not 1. Beta particle is 0 over negative 1, like this, so mass of 0. Neutron is 1 over 0, so that's probably our answer, and this is that. Neutron. Which statement describes the charge of an electron and the charge of a proton? So I know that electrons are negative and protons are positive before I even look at the choices. An electron and proton both have charge? Nope, they're not. They're different. Electron is -1, proton is +1. That's choice D. Compared to the charge of a proton, the charge of an electron we're talking about magnitude and size. So we just said in 35 that electron has a charge of -1, proton is +1. So they have opposite signs. And you see that they're both a magnitude of 1, which means the same magnitude and opposite sign. What is the overall charge of an ion? Ion means charged, that has 12 protons, 10 electrons, and 14 neutrons. So one of these 3, neutrons, doesn't have charge, so we don't care about that. So there are 12 positives, and there are 10 negatives, which means there are 2 more positives, which means we are overall +2. What conclusion was a direct result of the gold foil experiment, Rutherford? An atom is mostly empty space with a dense, positively charged nucleus. Yeah, that's it. An atom is composed of at least 3 different types. Nope. An electron is a positive. Nope. Electron is, nope. That's later. Okay. Given the particle diagram, so we have atoms, and they're all clumped together. Which substance at STP, standard temperature and pressure, can be represented by this diagram? So notice how the particles are clumped closely together. That is a solid. So which of these are solid? You need to know. So I know that nitrogen is a gas, hydrogen is a gas, magnesium, that's a group 2 solid. That is the alkaline earth metals. And krypton is another gas. So choice C for 39. Which electron configuration represents electrons of an atom in gallium in the excited state? So I'm going to go to periodic table. And gallium is on the ground state 2, 8, 18, 3. That's the ground state off the periodic table. So immediately I get rid of that because it wants excited state. So I also need to make sure I don't lose any electrons. So I still have to have the same total. I need to have 31 total. So 2 plus 8 plus 17 plus 3. Choice A. Doesn't have 31 electrons. You don't lose any when you go to the excited state. You just shift them around. So then the question says, well, hold on a second. I'm going to look at D. 2 plus 8 plus 18 plus 4. That's too many. So the answer is B. And you can see why. One of the electrons from here moved up. So that's the excited state. Choice B. What's the total number of neutrons in an atom of oxygen 18? When they give this to you in this way, this indicates an isotope. So that means the mass is 18. Don't look at the periodic table. Look at the one they're giving you in the question. So if the mass is 18, that is protons plus neutrons. So I have always 8 protons. So 18 total, 8 plus X. So it has to be 10 this time. Normally, the most abundant isotope of oxygen is oxygen 16. So it's got, normally 8, but it's not this time. All right. So here we go. Number 42, the total number of protons, electrons, and neutrons in each of the 4 different atoms are shown below, who are isotopes. So let's define them. Isotopes, same number of protons, different neutrons. That looks like no. N to the 0. And since you have different neutrons, your mass is different. But it doesn't talk about mass here. So first of all, we need the same protons. So A and D do have the same protons. That could be a choice. A and Z do not. X and D do not. X and Z do not. Okay, so that's our answer, but let's just check it. So same protons, but different neutrons. So it is indeed choice A. What is the isotope notation of the same element? So first of all, we have to have the same element, meaning the same number of protons, which is the bottom number. So 7 and 7, 7 and 10, nope. 7 and 10, nope. 7 and 10, no. So notice how they are both nitrogen, but the mass is different. This has 14, this has 18. It's because in this first one, we have 7 neutrons. In this other one, we have, what, 9 neutrons? Yeah. So that's it. The atomic mass of titanium, excuse me, is 47.88 atomic mass units. This atomic mass represents, okay, so this is defining atomic mass. It is the total mass of all the protons and neutrons. Unfortunately not. The total mass of all of the, no. The weighted average of the most abundant isotope? No, it's the weighted average of all the naturally occurring isotopes. This is a definition straight from our notes. Number 45, lots of numbers. We're doing average atomic mass, which means mass times percent abundance plus your next mass times percent abundance. You can either divide those percentages by 100, or you can take those percentages, make them decimals, which is what they did here. So it says 19.78 grams of boron, 10, and here's that. So, and this is tricky because they assume a 100 gram sample, so this is grams of boron would be 19.78%. So 19.78, make that into this. So I think it is choice A, because you would just move the decimal place 2 spots to the left in order to divide by 100 to make those into the percentages we need. The other ones don't add up. Number 46, at STP, which element is solid, brittle, and a poor conductor of an electricity? This is nonmetal. Those are definitions. But not only is it a nonmetal, it's a solid nonmetal. So that's a metal, that's a metal. Those are 2 nonmetals. However, it says solid, neon's a gas. Which statement describes the relative energy of the electrons in the shells of a calcium atom? So where are the highest energy? Think about a concert. If you're front row, you can see everything, you can hear everything, you're loving it, you're not putting a lot of energy into seeing what's going on and participating. If you're in the last row, it's hard to hear, it's hard to see, you know, people might be in your way. So you're putting in a lot of energy to participate. So an electron in the first shell should have lower energy than anything else. So first has more energy than second. First has the same, nope. Third has more energy than the second, that's it. Third has less, okay. When you go from excited to ground, well, first of all, to go to the excited state, you need to gain that energy by heating. When you're coming down, you're giving it off. So the extra energy is given off, which they're, you know, using a tricky word, emitted. That just means given off, okay? Which electron configuration represents an excited state for potassium? So first, let's look for ground. So periodic table, potassium is 2881, which means immediately that's gone because I need excited state. So if any of them don't have the same number for potassium, which is 19, you're also gone. So 2871 has, hold on. Yeah, that's not right. That's 14. Hold on. 2 plus 8 plus 7 plus 1. Oh, that's 18. Okay, so that's not it. Not the same number. 2 plus 8 plus 7 plus 2. That has 19, so that could be a choice. 2 plus 8 plus 8 plus 2 is 20, so that's too many. So see why B is the choice? It looks like one of our electrons from the third shell jumped up to the fourth shell. So it's the same number of electrons, just a different arrangement. Which atom in the ground state has only one unpaired electron in the valence shell? So it's going to have something dash 1 for its electron configuration. Aluminum is 2-8-3. Silicon is 2-8-4. Phosphorus is 2-8-5. And sulfur is 2-8-6. That doesn't seem to help us. But what if we did orbital diagram? So this is all the 3p. So we're going to pretend we just start there. So aluminum, we've got just the 1 because we've already done 1s2, 2s2, 2p, 6, 3s2. We've already done that. Now, I apologize. That is super messy. But we've already got 2, 4, 6, 8, 10, 12, 13. That would be aluminum. And it does have only one unpaired electron in the valence shell. So it is aluminum. And I don't need to go any further because this would just have another one, this would have another one, and this would have another one. So it is indeed A. Given these bright line spectra of the 3 elements, what are in the mixture? Okay, so this is only tricky because I got to follow it back up. So looks like D and E. Let's see. Is that straight? This is tough. This is tough. Well, D matches up here, here, and here. Is it E? E would match. D and E. Is there a G? I don't think so. Yeah, because G has all this extra stuff. So yeah, it's E and D only. But of course, even I'm checking. A specific amount of energy is emitted when excited electrons return to the ground state. So you can't find out any of this, but you can find out the identity. The bright line spectrum of an element is an identity. Bright line spectrum is produced as electrons are moving from high states to lower states. They have to go to the high states by gaining energy, by heating, and then you come back down, you give it off. In the wave mechanical model, an orbital is defined as a region of most probable location of electrons. Circular path, this is Bohr. And protons, you should know where those are, nucleus. As an electron moves from the 3s to the 2s, so this is moving down, energy should decrease. Remember, closer to the nucleus is like closer to the stage. You can see everything, putting in less energy to maintain. Base your answer. Orbital notation. So who is this? It's got 4 electrons arranged 1s2, 2s2. So who has 4 electrons? That is beryllium. which is a noble gas in the ground state. So I don't even need to really look this up because I know they have a full outer shell. This is orbital, but it's full. So who is full? Choice C. Which list of elements consists of a metal, a metalloid, and a non-metal? So remember that metals are to the left of the zigzag, non-metals are to the right of the zigzag, with the exception of hydrogen. That's a non-metal lurking on the left. And then along the zigzag, we've got the metalloids. So lithium is a metal, sodium is a metal, rubidium is a metal, so that's not it. Chromium is a metal, molybdenum is below it, metal. Tungsten is right next to it, nope. Tin is metal. Silicon is, metalloid. Carbon is non-metal. So that's our answer. I'm not even going to go any further. The arrangement of elements from left to right on period 4 on periodic table is based on. Okay, so if we're going from left to right, atomic mass, no. Atomic number, well, gee, that does tell me how it's arranged. Number of electron shells would be the same, and oxidation states is all over the place, so we're arranging them by atomic number. Most similar chemical properties are in the same group, which is up and down. So bromine is in group 17, so we want other ones that are up and down. No, gallium goes this side to side. Yeah, this is not good. Chromium is in group 6. Lead, nope. Oxygen's group 16. Chalcogen, sulfur below it, selenium below it. Compared to the atoms of nonmetals in period 3, metals have, okay, so just period 3, looking at the metals, sodium, magnesium. So do they have fewer valence electrons? Sodium has 1, magnesium has 2. Yeah, they do. So that's our answer. Excuse me. Electron shells would be the same. If an element X can form an oxide, that would be X2O3, where would it live? In the same group. So let's first figure it out. If you're X2O3, oxygen's a -2 charge, so that gives me -6, so I need a +6. So X has to be a +3. So barium is got a +2. So if it's in the same group, it would have the same charge, so it's not me. Cadmium, where are you? Okay, that's a +2. No. Indium, +3. Sodium, +1. Yeah, so it's indium, 62. Which property can be defined as the ability of a substance to be hammered into thin sheets? That's called malleability. At STP, which is a good conductor of electricity, these are metals. So chlorine's a nonmetal, iodine's a nonmetal, sulfur is a nonmetal, silver is a metal. XF2, who is X? Okay, so F's a -1, so that gives me overall -2. X has to be +2. So first of all, nonmetals, no, there's no group 1 or group 2 nonmetals. So if you are a +2, you're going to be in group 2. This is halfway, so this is where this video is going to stop. If you want anything beyond, check the second video. Thank you.